Hello, everyone. Okay, I guess we're ready to start, and I'm really excited to be here. Today, I'm going to talk about RavenDB and AI, and specifically how you can use AI inside and around RavenDB. I don't know if this is actually being expressed, but I'm actually really excited about this, mostly because this is so much fun, both to actually develop those features and to actually show them and have concrete cases where they're going to be extremely useful. So let's talk about AI for a bit. Well, you know that. You know everything about it probably. You're using ChatGPT, you're using a Copilot, you're using live coding, hopefully not, etc. But basically, you add AI to something and you get VC money and probably it gets better. So the problem with doing that is that adding AI to something tends to require that you know a whole bunch of stuff, most of which are pretty complicated. Matrix blah, 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 blah. You can say I cannot even say that. Matrix multiplication on GPU, and then understanding what it actually means, and attention is everything, and blah, blah, blah. If you're not actually a machine learning nerd, etc., that's probably not your cup of tea, except that this is now a cup of tea with AI in it. So let's talk about where we actually are and where we want to go. So I don't think that you want AI inside of database because to start with, your database server doesn't have a GPU. And I actually went ahead and checked, and a GPU instance costs about more than twice as much as a non-GPU instance. And another aspect of AI, and I think that everyone has seen that to at least some extent, is that you have something that sometimes gives you amazing results, and sometimes it hallucinates everything. You ask it, give me some code to do a task, and it invents an API. It invents packages. It invents everything for you because it makes sense, because it's effectively a statistical model. But the key aspect from my perspective when we talk about databases, database should be boring, should be reliable. It shouldn't be a toss of the dice. So let's talk about how we want to integrate. An easiest way to integrate is to do an AI agent, right? So take a model, train it on RavenDB, how it works, etc. We got lots of documentation. Just throw that into that, train that, and you're done. And we are actually doing that, but we're doing that by having a bunch of students do a in-industry project to do that. Because it turns out that if you go and ask Grok or OpenAI, so this is Grok and this is OpenAI, ask them that. They already know this. So that information is not something that you have to do something special for. It's already out there. So what do we bring to the table? Earlier this year, I think earlier this year, or maybe late last year, I cannot remember anymore, but we released version 7.0, and in that version, we issued minor feature, vector search. And what does vector search has to do with AI? Well, it turns out that quite a lot, because of something called embedding. Vectors embedding is the same thing. And a vector or embedding is basically an array of numbers that represent how the model view a piece of data. And that turns out to be really interesting because if the model considers two pieces of data to be close to one another, that very likely means that they are connected based on the training model that we have, which doesn't actually make sense, right? This is very abstract. So let's talk a little bit more about that. Look at this query. If you go now to any 7.0 version of RavenDB, You run this query, you get these results. And you're searching for Italian food and you get pizza, pasta. In fact, here we have the RavenDB sample data. I'm going to run this query. Here is mozzarella and ravioli, and everything else is not that close. And that's interesting, because the first time I saw that, I was absolutely amazed. Because think about what this means. It means that I have Italian food and I have pasta, and the model puts them close together, closer than, I don't know, Taco Bell. Then if I'm searching for Italian food, I would get pasta, and then I would get Taco Bell. That's amazing. That's amazing because it means that in terms of the complexity and the richness of my searches, now I have so much more power. Now, let's go a little bit deeper. So we have a piece of data, we run it through the model, we get a set of numbers. Typically, those are floats. There is something between 256 to 3000 something. And think about what this means. 256 floats is 1 kilobyte. 3072 floats is 12 kilobyte. Those are big things. That's a problem. But the key aspect about this is that when you think about it, if a vector, an embedding on its own doesn't mean anything. Just that you can compare it to one another. How it works is outside of what I want to cover, is gradient distance, costing distance, all much further stuff. Basically, multi-dimensional math, which can be fun, can be incredibly annoying, especially if you need to make it work very fast. And that's about it. So let's see how it looks. What you have here are two models that look at the same data, but they have different concepts. So this model decides to group things by how close they are by color, which makes absolute sense. These things decide to capture them by functions. This is for adults, this is for kids. So this is a very visual representation of how it works. Now, neither one of those embedding is correct, and there is no actual meaning for the embedding except the context of its model. So now, here I'm running the same exact query, but here I'm using the default model inside of RavenDB. Here I'm using the OpenAI model, which is this one. This is using this is a very small embedded model. This comes with RavenDB, and it is intended primarily for testing, evaluation, just making sure that everything works out of the box. When you want to run on realistic numbers, you typically go with this. And you can actually see how those numbers are, those results are more accurate. Gnocchi is certainly very much an Italian food, as is mascarpone. But Gamma Mix is what this thinks is closer. Okay, makes sense. So different models have different results. Typically, you want to use models that are more sophisticated, but to give you more context. The problem with that is that the bigger models are also slower, more expensive, and they generate bigger embedding, bigger vectors. And those bigger vectors are much more accurate, maybe, but it doesn't mean that, oh, wait, I actually care about this level of accuracy. Consider the fact that if I'm using a 12 kilobyte embeddings, then that means that for minor records, I'm going to use 12 gigabytes just for that. That's insane. And it goes, so there are ways to handle that. Either use smaller models or use something called quantization. We'll talk about it in a bit. So an important aspect here is that how do you generate the embeddings? Well, you can go and ask OpenAI, for example, or Grok, or any of the models. You give it a text, and you get back a vector representing that text in the model, which is great. But there are issues with that. First of all, if you want to run it, it's expensive. What do I mean by that? It means that you're paying for each one of those calls, and the more data that you have, the more obviously you would pay. It is got to the point where this is one of those things that you put in the yearly budget. This is how much we're going to spend on AI. So whenever we start talking about AI, and I'm assuming you're familiar with the limitations of GPU. I'm talking about limitation of supply of GPU. I want to buy a GPU, then I can't because there's not enough being produced to meet demand. So that means that anything that uses GPU is more expensive. So now let's talk about what it takes to actually do that. It means that I need to generate embedding for my data. That's relatively simple. I have to update the embedding whenever my data is updated. I have to run the embedding whenever I want to query. And that turns out to be quite complex. To give you some context, this doesn't look like much, right? And this doesn't look like much, but behind the scenes, think about what it means. I'm giving you a text, I'm not giving you a vector. So in both cases, RavenDB goes to the model and asks it to generate the vector form. Now, it's something that you have to do, obviously. But the fact that you don't have to do that manually means that this is so much easier. And the fact that we do that means that we have a lot more opportunities to deal with the logistics. It means that I can start applying caching, I can start applying all sorts of best behaviors in order to handle that. So let's talk about the following scenario. I took my blog, and my blog is obviously running RavenDB. And you can see here all of the posts. Okay, there are 7,550, and that's a lot. That's more than 21 years of writing blog posts. And I run some embedding tasks just for the titles or for the titles and the bodies. Let me show you what this looks like. So this is the title, and here I have some HTML. And this is pretty big item, if you notice. And I can go here, and this is new in 7.0, and I can connect RavenDB. In this case, you can see that I'm connected to OpenAI and text embedding small. This generates embeddings that are about 6 kilobytes in size. And then I have this. I have an AI task that is going to go over all of the posts. It's going to generate embeddings for the title. It's going to generate embedding for the body. And now we have to think to talk about a whole bunch of things here, because this screen is actually really busy. So let's talk about this. First of all, we have something called max tokens. So there is only so much context that you can provide to the model before it will give up. The typical number is from 2K to 8K, and sometimes it's 128K. But again, those tend to be really rare and quite expensive. So right now I'm saying every 2048 tokens, split it. Now, in this case, I have just plain text. In here, I have HTML. I don't care about that. So I'm asking RavenDB to just strip it outside. And the whole idea, you can see here, we have a whole bunch of options here. It means that I don't need to worry about any of that. RavenDB goes ahead, does it for me, and then I can live in peace and quiet. That also leads to a really interesting observation. let's see what this does behind the scenes. So here we have the posts, and now we have this guy. So let's go and look at what was that? Okay, and remember, this is a pretty big file. So now you can see here is a couple of attachments. This is for title, this is for body. What is this? This is, if I open that, this is a binary file, 6 kilobyte in size, that contains the vector for the body elements. And you can see it for each one of those. Okay, 6 kilobyte for each. Now I have this, and this is also an embedding. So the idea here is that, and this is really important, this is a cache. This is a cache that it is whenever I need to generate an embedding, I'm going to force check whatever already run this embedding before. What does it matter? It matters because, as you recall, this can be really expensive. So the fact that I don't need to do that and I can remember when this happens and avoid that means that I have a much better place to be. I don't have to waste money. I don't have to think about it. It also means that you can see that I'm storing it here, but there is another location that I'm storing that, which is the associated post. But because both of them are using attachments, then we actually take advantage of a unique keyfind feature in RavenDB, where attachment is only stored once, regardless of how many references we have for that. So that actually saves us in space tremendously because we don't have to store both the item for the post and for the cache. Now let's go here and talk about this. This is 6 kilobyte. I can also specify additional quantization methods. And quantization is basically taking the same data and making it smaller with some loss of accuracy, but still relevant enough. And that means that, okay, it's no longer as accurate, but it's close enough for what I need and what I want, so I don't have to worry about that too much. I can go all the way down to 1 bit per value. So instead of taking 6 kilobyte, I would actually have to take something like, let's see. So we have, and now we take 96 bytes. So that's wow smaller. And this is divided by 4 or something like that. So ridiculous amount of savings. Now, you can also see here that we have a cache here, and the cache would expire in 90 days. So this is this guys. You can see that this will expire in 90 days, and then I will delete it. But I will not delete it if someone is actually going to regenerate it. So all of that is handled for you, and you don't need to think about it. We also have the same approach for querying. This is when I'm doing this. So again, I can apply my own behavior here. If I know that user is providing with HTML or whatever, I have control over that as necessary. But the key aspect here is that most of those things are not things that you have to worry about. Give me your fields, tell me what you want to do, and you're done. If you want to run advanced stuff, you can do that. You can go to as advanced as you want. But for the most part, it doesn't matter, and you can do something as simple as that, and that works quite nicely. So we talked about this. Just to give you some context, I ran this on the titles and bodies, and it took about 3 minutes, and it cost me about 8 or 9 cents. So this is not a lot of data, especially if you do the HTML stripping. But those are the sort of things that you have to really think about. Now, let's say that I'm going to go ahead and update the blog post. And that's something that I do quite often. What would happen then? Well, this is going to rerun. And it's going to say, oh, I need to send it to the model. But because I'm using it, because the title and the body did not change, let's say I update the published it, then I get to lean on the cache here and not have to go to the model at all. And this is really simple when you think about it, but it has a profound impact because you no longer have to think about it. Updates are just headers for you, and you're done. If you have a value that is shared among multiple fields, multiple documents with the same field, which is really common, what do? I'm a developer. Okay, so I don't have to ask for each individual developer. I've already done that. Okay, so let's talk about vector indexes. Here's what I have here. And this works together with the embedding generation. So the whole idea is that I'm loading the title using the post via OpenAI. And the way that this works is that I have this guy. Here is post via OpenAI, and here is the title. This is how I know which attachment to go to. What is the associated vector from this behavior? And the nice thing about it is that, look at this. I'm asking for good interview questions based on the title. But I can also talk about and notice that now I had a much lengthier query time. Why is that? Well, this is the fourth time I run into this query. So I had to go ahead and generate an embedding for it. You can see it here. This is the embedding. And this is again 14 days because this is a query. This is the default. This is the embedding that was generated for good books to read. And apparently I'm reading quite a bit, but sadly not for a long time. And now think about the impact of this for your scenario, where you're reading, where you're querying over using intent. That's actually really, really cool. So this is semantic search. This is the appropriate term for doing that. Now, let's talk about something else. Let's say that I'm looking at a particular document, and I want to find similar documents. This is the classic recommendation systems. So you read this blog post, what other blog posts do you want to see? And this is actually a problem because I'm not using the appropriate index. I'm sorry. Hopefully this will be the worst. Hopefully this will be the worst demo nastiness that we'll encounter. And now I can go and so this is the document that I'm starting from. And here are things that are similar to it based on the content of the body. Interesting enough, if I'm going to use for this one, so this is optimizing facet performance. You can see how it works. So now I have everything about optimization. Now, this is pretty cool, even if I say so myself, mostly because of the reason I'm saying that is think about what it would take for you to implement this sort of feature. Now you can do it like this, and you're done. So this is really fun. Another really important aspect in AI integration is the concept of RAG, retrieval augmented generation. So I decided that I want to show you how this looks like for RavenDB. And here you're asking questions about something. And what I'm doing here, I'm doing multiple steps. So the first thing that I'm doing, I'm asking Raven, give me everything that match, give me all the top 5 of the post titles that match this query from the user. And then I take this thing, I'm taking all of the titles, and I'm passing that to, in this case, to Grok, and I'm asking, hey, answer this query with this context. So now I'm providing additional context to the query to operate on. And now I have an answer. So the whole idea is that I now have single slide amount of code that gives you RAG integration inside of your database, on your own data, on your own logic. And the beautiful thing about this is that this is not something that you have to build, to think, because if you go to Azure AI, for example, and I want to implement a RAG project, then the typical answer would be, of course, let's talk about the many, many pipelines that you have to build in order to make it happen. And I'm talking about many, many, many pipelines and quite a bit of complexity that is involved. So with RavenDB, you go like this, define the data, you specify search, you provide the data to the model, and then you're pretty much done. You have concrete information based on your actual data. And I think that's really, really cool. Okay, so we talked about embedding, we talked about caching, query handling works in pretty much as I hope you expect. Whenever you want a query like this, you see that now it was much faster. Why was it faster? Because I didn't need to go to the model to generate this. I could just use the cached value. Again, going to the model is expensive. It's expensive on multiple levels. First of all, it means that it is expensive because the amount of network latency that you pay is significant. It is also better to submit bigger batches to the model. So all of those things are stuff that we are handling behind the scenes for you, so you don't have to worry about that. But that's about it. This is what happened behind the scenes. It's not that scary. It's just a tremendous amount of details that you have to deal with, and except that now we have to deal with it, and you don't. Okay, I'm trying to not get too hung up on these features, but I absolutely love it. So this is when we talk about bringing, so far we talk about methods, we talk about embedding generation, now we talk about GenAI. And the first thing that pops to mind when I'm talking about this is, what does this mean? What does it mean, GenAI in your database? And before I start, I'm going to show you a preview feature. This means that I'm going to show you stuff that works, but the UI is still very rough. Don't get too hung up on that. We're going to do a cleanup on that and do this point. But let's talk about what this means. What happens if I could ask the database, hey, I have a bunch of recipes and I want them translated into different languages. So let's go here. And it turns out that I actually have a bunch of recipes. And this is low-cook cream fudge, whatever that means. And what I'm going to do now, I'm going to show you we have two AI tasks now. This is the embedding generation. This is what you have right now in 7.0. This is new. This is GenAI. Let's talk about what we have here. So let's use this there. Okay, smoked salmon, quinoa, and dill lunch pot. And what you can see here is that we have a bit of JavaScript that output some context from this document. So this is going to take these two fields and pass it to the model. And now we have this guy. Translate the recipe name, the description, blah, blah, blah. I can do this. And unfortunately, I have to do this for a reason we'll explain shortly. Now I'm going to run this. And this is going to run this script on the document, send it to the model, and get results back. So here you can see that we have a context, smoked salmon, quinoa, and lunch pot. And here we have Hebrew and German only. That's annoying. Maybe it's like Russian is better. I don't know if saying please will help, but I hope it does. Okay, so I have an issue here, and the issue here is that data is probably cached, and the next stage is to take this data and push it into the output. Now you can see it here. The reason I had to do F1 here is that I already run this over all of the data. And I have this AI hash here that allows me to say, oh, I already done this. I already run this operation, this prompt over this data. So if I would just run this, I would get this result. Oh, this is cached. I don't need to do anything. But I think there is another level of caching behind the scenes that I'm hitting, which is why I'm saying this. Maybe I can do something. Let's try being slightly more annoying. There's actually no meaning to what I'm doing right now. So the F2 or F1 is just a random value that I'm putting to distinguish that. Oh, I know what's going on. Okay. So, okay, I mentioned that we have a bug in the UI. The bug is that it is not reading this value. It's reading the stored value. That's the problem. So if I want to do it properly, I would have to do here. I would take you through the whole thing. And go with that, but I really want to show you. So here, and I will explain exactly what's going on. Make sure that this box. Okay, so again, this is cached, so I'm not seeing that, so I have to cheat with this. And that will run the result, ask the model. Right. Oh yeah, okay, that makes sense. And now we have Hebrew and French. And now I should be able to do I hate that I figure out a bug while I'm doing the demo. Then again, I love that I'm being able to show you this as early as possible. So now we run this. And now we can see how it all fits together. And I have no idea. I don't read German or Russian. This is more or less okay. And now this is the output option, where I'm taking the output from the model and I'm pushing that in here. So the whole idea goes like this. I have this input script that run over the document and output the context that I need for the model. I'm providing the prompt in a sample object, or I can operate the JSON schema. And the whole idea here is that I'm telling the model how do I want the output to look like. And we're using a relatively new feature called structured outputs. And the whole idea here is that I'm getting the JSON back, and you can see I can modify this as necessary to get the right results. And then here I'm sending this to the model, get the results back. This is some information about the model. This is how much it took to prompt, to completion, blah, 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 some statistics, etc. And at the end of the day, here is the translation. I love the example of doing translations, because think about what this means if you had to write your own process to doing that. That's a lot. But let's see another example. This is how I feel sometimes when we have, why did we make things so complicated? We used to have text, and text was good for everything. So let's go and look at resumes. Here is some resumes that I have. Okay? And as you can see, this is a whole bunch of text. Whole bunch of text. I don't want to read that. I want to get information from that, but I don't want to read that. So now you can see here is some structured data. This structured data was not provided by this user. Instead, this was provided, as you can expect, by the model itself. So here I'm providing the context for this model, which is, whatever necessary. Here is the prompt, and here is the expected output. Based on those two items, it is actually able to generate concrete information about how this should work. So now it is able to take unstructured data and make something of that. And you can think about quite a few scenarios where this is really meaningful. For example, if I have I'm going to use developer examples because they're easiest. Let's say that I want to tag an issue on YouTube. I want to say, hey, what version does this apply to? If you ever submitted an issue to Microsoft, then you know that there is a whole tagging system behind the system. Someone is actually reading through that and saying, oh, this belongs to this version or that version, etc. And now I have a tagging system And this is basically what we're doing here. Read these texts, extract the relevant information. And we can see that it works. Now, remember that I spoke about caching earlier? It's important, and we're actually running into problems because it's been aggressively caching for us. And this is because GenAI can be expensive. If you run it over 1,000 items, it's a that. So most times I only want to change that, want to regenerate that when the information has changed. So let's look at what I have here. You can see that the output that I have contains this AI hash. And this AI hash is computed from those two, because that's what I provided for the context. As long as I keep returning the same items, I get to skip the work that is associated. Again, this is a relatively simple concept to grasp, but it has huge impacts of, I don't have to be concerned about that. Because whenever this document is modified, I would run the GenAI task. But the GenAI task is also modifying the document. The fun thing about this is that we are not only limited to modify the document. We can do stuff that is not more complicated. I went to GitHub and I pulled an issue. You can see here, this is an issue. It went for a while. There was a whole bunch of back and forth. The scenario here is the user has a problem with certificate with a password. So I decided to do this. Run over all of the items that we have in the document and provide that to the model. And then I'm asking it, tell me if I need to escalate or not. And if I need to escalate, also tell me why. And the nice thing about this is that if I need to escalate, I'm going to create a new document for this. And going to save this. I'm going to change something here in the body. Yeah. Okay. Now, in a few seconds, this is going to rerun, and we're actually going to see the changes, because what I asked it to do, and I hope this actually works. Yeah, so I should have this output. Okay, that's annoying. Do this, force it to run. Great. What did I do wrong? Okay, so for some reason it doesn't like me. Not sure why. Model E. Let's move that. And hopefully this will run. Or not, because this is annoying. Okay. So as I mentioned, I don't like when the demo does that. But let me show you something nice. You can see here's the work history. And I'm going to say and just hit save. And assuming they haven't messed up too much, I'm expected to see that this was updated. Okay. Now notice what we have here. Here is no print code. So what you can see is that I remove this. And again, time to update, to go to the model, update, whatever. And then this gets updated and I'm back in this case. So the whole idea here is that this opens up a whole new approach for you of give a prompt, tell me how to update your documents, and then just let it run in the background and it will continue to enhance what you're doing. So we talk about this prompt in the context, we send it to the model, and the caching and hashing that is involved. There is quite a lot going on behind the scenes, which under the headline of logistics, which is the caching, the handling of rate limits, stuff like that. It seems silly, but look at the recipes. As a good example, I have over 1,000. Well, the default approach for the default limit for OpenAI, for example, which I'm using in this demo, is to have a limit of 500 requests per minute, which means that if you run through this, then you would hit the limit, and then you'd have to recover. And we had a lot of that. We would have to process ourselves with that. Also, with all of the associated costs, etc., and you have the appropriate metrics for knowing where everything is and costs, etc. Okay, and to complete, RavenDB is mostly about AI. We started with vector search, engine generation. Now we have retrieval augmented generation, RAG, as you see, and then we have GenAI with all of the options that you have for that. I think one of the key things that I like is that I'm actually, and I don't think that I actually gave it enough space. If I'm looking at this task, annoying as it is for not doing this, I'm asking the model to make determination on my data. And then I can take action based on that. That is really, really cool. But think about it. Now that means that I have the ability to very deeply integrate the AI model in my application. At the same time, I don't have to call OpenAI or whatever model I want to use for my system. Everything is handled in the backend. And if I wanted to, what happened if now I have to have some additional process for handling the escalation? Well, I can use the existing features, such as a subscription, to listen to new escalation documents and run some code around that. This also deals a lot with how you actually work with that and how you work with AI safely. So I haven't mentioned that, but in terms of RavenDB, we have support for quite a few models. And if you use, most models have support for OpenAI, so you can use the OpenAI model to talk to all of them. You can use the embedded one, which again, mostly for demos and testing, not for real big time use. But the key aspect here is that we assume that you're running your model externally to RavenDB, whatever you're running that on your own instance or using OpenAI, etc. The reason this matters is that when you do that, you shell out all of the complexity outside of the database. You don't want to see a database basically crawling because an embedded task is taking 100% CPU. And at the same time, you don't want to have to go and buy a GPU for your instances. So you get that also means that if you're running your own local model, I want to run on DeepSeek or on my own instance, so I don't send the data to OpenAI, that's something that you can do very, very easily. And with that, I want to open the floor for questions. And we have a question from Danielle about prompt caching, which leads to, hopefully you won't get too bored on that. So let's talk about how the model actually processes data. So when you have a model that needs to process many different requests, then the way that the model works is that it works in steps, and you can start thinking about like streaming, and you stop in the middle of the streaming operation, and you can resume from that. So that's why if you want to provide when you structure the prompt, the static pieces have to go on the front, because then you can benefit from prompt caching. And that's basically the way that it works. So we are actually doing a lot of stuff behind the scenes in order to make things as optimal as possible for your scenario. Okay. If you have any additional questions, this is time to ask them. If you think about this later, this is my email. I would love to hear from you. And let's see. Give it another few minutes. I don't know if it goes through when I'm talking, but I am really excited about this feature because of the kind of thing that it enables you to do. I want to be able to classify my blog comments to spam or not spam. And it seems like a silly, it's a silly feature. But, and you can build that with not too much trouble, but now I'll be able to go and do that at database level and not touch the rest of the system. And this level of isolation is really good from our perspective, because it means that we don't have to fight over what's going on. I don't have to deeply understand everything and try to figure out where everything works in AI models and different AI models, etc. I can just ask RavenDB and have it. Okay, thank you everyone. Have a great night.